Is a low carb diet ruining your sleep? Let's talk about it. I'll see you inside. So, the main neurotransmitter that everyone really needs for sleep is melatonin, and we need melatonin inside of the brain. Now, melatonin can be made in the brain from serotonin, and to make serotonin, we need an amino acid called tryptophan. In the brain, tryptophan goes through what's called hydroxylation to form 5-hydroxytryptophan. Then 5-hydroxytryptophan goes through what's called decarboxylation to form 5-hydroxytryptamine, or 5-HT. And a much shorter name for 5-hydroxytryptamine is serotonin. And this serotonin can be transformed into melatonin when we experience darkness. So we now kind of see why tryptophan is important for the production of melatonin and therefore sleep. But let's talk a little bit more about what tryptophan is and how we actually get it inside of the brain. So tryptophan is referred to as a large polar amino acid, and amino acids are simply just the structural molecules that make up proteins. And now, it's not actually 100% agreed upon about how many amino acids there are in the human body and how many are essential and non-essential. But the general consensus is that there are 21 amino acids and 8 of them are essential. And an essential amino acid simply means that we do not have the metabolic machinery inside of us to make the amino acid, therefore we must take it in from our diet. And now most proteins, at least animal source proteins, have all of the amino acids just in different concentrations. And the foods that have the most tryptophan are actually milk, meat, fish, and eggs. And now the structure of amino acids are very, very similar. And the result is that amino acids oftentimes have to compete with one another to enter through a given amino acid channel for access to a specific area of the body or brain. You can think about it like a bunch of people trying to leave through the same door. The people who are closest will leave first and the quickest, and the people in the back will have to wait for the people in front to get out first. And this is why it's so difficult to try and take a single amino acid supplement and feel confident that that amino acid is getting exactly where we want it and doing exactly what we want it to do. The uptake of an amino acid into a given tissue is not only dependent on the concentration of that amino acid in the bloodstream, but it also interplays with the concentration of all the other amino acids and all of the nutrients that require the amino acid to be processed and utilized. And now, in order to make more melatonin in the brain, we will need more tryptophan inside of the brain so it can be biotransformed into serotonin and then melatonin. But to do so, we actually need to get it through what's referred to as the blood-brain barrier. And this is a network of blood vessels and tissue that are closely spaced cells that keep harmful substances from reaching the brain. And the barrier has different channels and permeability to different molecules so that some substances like water, oxygen, and amino acids can enter into the brain, but other things in the blood circulation cannot. So, interestingly, tryptophan can get into the brain through a transporter, which transports it across this blood-brain barrier. However, this same transporter is responsible for transporting different amino acids like isoleucine, leucine, tyrosine, valine, and phenylalanine. So what this means is that all of these amino acids are actually competing for the same transporter. And the more of the competing amino acids that there are, the less tryptophan is available to get into the brain. If you have the same given amount of tryptophan, the less of the other amino acids you have, the more tryptophan will have access to this transporter and enter into the brain. And this is what I want to talk about today. So I've talked about insulin before in the past, but insulin will actually help facilitate the uptake of amino acids out of the bloodstream. Which means if we are able to actually increase our levels of insulin, we will pull more of the competing amino acids out of the bloodstream, leaving tryptophan available for the brain. Conveniently for us, it appears that all that matters is getting tryptophan into the brain at least one time during the day. So we can even do this in the morning and have the tryptophan available to make serotonin throughout the day, and then have that serotonin available to produce melatonin at night. And remember, the catalyst to turn serotonin into melatonin is darkness. Not only darkness at night, but low blue light exposure 2 to 4 hours before bed is also helpful as well. And it appears that to get the greatest amount of tryptophan uptake into the brain, the higher the glycemic load of a carbohydrate is, the better. The glycemic load of a food is determined by how much it raises your blood glucose levels. And typically this is a bad thing, but in this scenario it can actually be beneficial. So the higher our blood glucose goes, the more insulin we will actually produce. And the more insulin we produce, the more of the nutrients will be taken out of the bloodstream and facilitated into the cell. And obviously there are negative ramifications of having very high blood glucose and very high insulin all the time. However, a high degree of insulin can be used in some circumstances to facilitate better nutrient uptake into the cells. And in terms of a high glycemic food, we actually will produce more insulin for the same amount of carbohydrates. Therefore, 30 grams of a high glycemic carbohydrate will cause more insulin production than 30 grams of a lower glycemic carbohydrate. So this could actually be useful if we're still trying to even restrict our carbohydrates. We can actually get more insulin production and more amino acid uptake out of the same amount of carbohydrates. This is where I would not turn to something like a candy bar, but I would probably turn to something like a fruit. With that being said, we're still going to want to make sure that we actually have the tryptophan in the first place, or this insulin spike becomes kind of useless if we're trying to get tryptophan into the brain. So we will also want to ingest foods like protein that actually contain the tryptophan. And now we could get the same insulin spike from just ingesting protein, specifically a fast digesting protein like a whey protein. However, the reason that I would say that carbohydrates might actually be more beneficial in this scenario is because if we're using the whey protein, we'll also be increasing the levels of all of those competing amino acids. So while we have the insulin spike and we have the tryptophan, we'll still have a lot more competing amino acids, so we may get lower tryptophan uptake than if we got the same insulin spike using carbohydrates. And now, technically, there is another way to do this, and this would simply just be taking a tryptophan supplement on an empty stomach. And now in the morning, before we've eaten anything, we'll have much less of the competing amino acids in our bloodstream, and the tryptophan supplement will work to increase our levels of blood tryptophan. And now the last way that we can really help boost our tryptophan uptake into the brain is exercise, because exercise will increase the signal to uptake amino acids from the bloodstream into the muscles, once again decreasing the levels of the competing amino acids. However, I would not recommend that someone would take an abundance of tryptophan, specifically in the form of a supplement, if they have high cortisol and chronic inflammation. So only about 10% of the tryptophan that we ingest actually goes down the pathway of creating melatonin. The other 90% actually will go down what's called the kynurenine pathway. And it appears that cortisol, likely from stress and inflammation, will increase the likelihood that tryptophan is converted into kynurenine. And this is because it appears that this kynurenine pathway is very important for the immune response. So if we have inflammation and we're trying to upregulate our immune system, we'll actually increase the tryptophan conversion into kynurenine. And this is actually quite an elegant pathway because inflammation is actually a signal of stress, and one probably would not want to be sleeping or tired in times of stress. Therefore, we would actually steal the tryptophan from serotonin and melatonin, which may relax us, and convert it into kynurenine, which will upregulate the immune system and cause much more immune system activity. And now the time this pathway seems to be most elevated is actually when someone has an illness, meaning they have chronic inflammation. And this seems to actually be contributing to muscle atrophy and sarcopenia in many ill patients. The kynurenine pathway actually decreases protein synthesis and results in what's referred to as muscle wasting. And this could also be contributing to why many ill patients report not being able to sleep. Simply, we are putting ourselves in a very overactive immune system state, and we aren't producing the serotonin and melatonin to relax. So all I simply advise is just to be careful with supplementing tryptophan, and really if you have any adverse symptoms from eating foods very high in tryptophan, you could have a dysregulated metabolism of tryptophan, or you may have some underlying issue that's causing inflammation. And the most important thing is not to take any of this as medical advice and consult with your doctor before making any changes to your diet and nutrition. So, to wrap this all up, the main takeaways would probably be that it's almost always important to try and mitigate stress and inflammation as much as possible, but I'm sure you didn't need me to tell you that. And the other takeaway from the beginning portion of the podcast is that getting tryptophan into the brain is extremely helpful for sleep. And there's lots of different ways we can try and do this, but it appears that the ingestion of carbohydrates in order to purposefully increase our insulin levels can help pull the competing amino acids out of the bloodstream and put tryptophan into the brain, or at least give it the best chance to enter the brain without much competition. So if you are currently on a low carbohydrate diet and you may have difficulties with insomnia or poor sleep, you could look at this solution of taking a very small amount of carbohydrates sometime during the day when you have a lot of amino acids in your bloodstream, specifically tryptophan, and then seeing how this impacts your sleep. So I hope you found today's podcast interesting, and I hope to see you next episode. Thank you